2016. If the radial and cross radial components of velocity of a particle are lambda r square and mu theta square respectively. Find the equation to its path. So here radial and cross radial acceleration is given. These are the lambda r square and mu theta square. Lambda mu are some constants. So by the radial and cross radial component of velocity, we know that VR, radial component of the velocity, radial component of velocity VR, this equals to dr dt, and this is given that this is lambda r square, and cross radial component of velocity v theta is equal to r d theta dt. This equals to mu theta square. First equation is call it 1 and second equation call it 2. So from here lambda and mu are constants, where lambda and mu are constants. From 1 and 2 we get r dot by r theta dot dividing 1 by 2 is equal to lambda r square by mu theta square. This implies dr dt by r d theta dt, this equals to lambda r square by mu theta square. So separating the variables, we write this dt cancel, so dr by r cube, this r square and r, so r cube, we write this mu dr by r cube equals to lambda d theta by theta square. Integrating this, we get this mu into 1 by 2r square, this equals to lambda by theta, plus some constant c. C is an arbitrary constant. C is an arbitrary constant. And this equation is the equation of the path. Here lambda mu constants and r theta are variables and c also arbitrary constants. And from this equation you can easily find the exact equation of the path if the initial conditions are given. But here no initial conditions, so this is the required equation of the path. This is the required equation of the path. This is the answer. Extra part for this question: the radial and cross radial component of accelerations are the radial components of accelerations. This equals to Fr. This equals to r double dot minus r theta dot square. So using 1 and 2, equation 1 and 2, this equals to r double dot. R double dot means 2 lambda r r dot. 2 lambda 2 lambda r r dot. R double dot means this minus r into theta dot. Theta dot means this is the 1 by r square mu square into theta to the power 4. From equation 1 r dot equals to lambda r square, so r double dot equals to lambda into 2r into r dot. So from this r double dot equals to 2 lambda r into r dot. Here dot denotes the differentiation with respect to time t. And from the second equation, r theta dot, actually this is the cross radial component of the velocity, mu into theta square, it is given from equation 2. And from this relation, theta dot equals to mu theta square by r. This theta dot square, so this square and this is the square. So mu square theta to the power 4 by r square, and this is the result. So by 1 and 2 we get this result, by 1 and 2. After simplification, you can write this 2 lambda square into r cube, 2 lambda square into r cube, because r dot means lambda into r square, so put this r dot by lambda into r square, so this is the lambda square r cube, minus 1 by r cancel, is the mu square into theta to the power 4. This is the radial component of the acceleration. So cross radial component of the acceleration, cross radial component of acceleration, this equals to say f theta equals to 1 by r ddt of r square theta dot. So this equals to 1 by r ddt of r square theta dot. Theta dot from 2, theta dot means mu theta square by r. Mu theta square by r from relation 2. R cancel, and so r mu theta square. And after differentiation with respect to time t, this equals to this mu constant. So mu by r is equal to, after differentiating this, so this is the r dot into theta dot theta square plus twice r theta into theta dot. Replacing r dot by equation 1, so mu by r equals to lambda into r square into theta square plus 2, and value of theta dot is this mu theta square by r. Put this mu theta square by r, and you get mu into theta cube by 1 and 2. R cancel, and so after dividing by r, so this mu into lambda into r into theta square plus 2 by r into mu square into theta cube, and this is the cross radial acceleration component. And so the resultant acceleration F equals to root over of f r square plus f theta square, and so after simplifying you get the result. Next question. A particle is moving in a circle with uniform angular velocity omega about its center, so that its angular velocity about any point on the circumference is also uniform and find its value. Particle is moving in a circle with uniform angular velocity omega. So uniform angular velocity means constant angular velocity, that is d theta dt equals to omega about its center, so that its angular velocity about any point on the circumference is also uniform, is also constant, and find its value. So here first we draw a circle. Suppose this is the circle. The center is the O. This is the horizontal line OX, This point is A. This any point P. So this the angle is theta. Now B is another point on the circumference, and particle is moving in this direction. We join this B and A. And this is the chord BP, and this angle is theta dash. Here P be the particle. Let a particle P is moving in a circle, is moving in a circle with uniform angular velocity, uniform angular velocity omega. It is given. So here the particle P and is moving in this way on the circle with center at O with angular velocity omega. This is the angular velocity omega. Let angle AOP equal to theta. All angle are measured in radian. This is the angle subtended at the center center O by an arc AP. So theta is the angle by an arc. This arc is AP. And let angle ABP equals to theta dash. See the figure, angle ABP. This angle is theta dash. Angle ABP is angle theta dash. This angle is subtended by at any point B on the circumference, by the same arc, AP. So by the same arc AP, this arc AP, B is any point of the circumference. So theta dash is the angle at any point B on the circumference by the same arc AP. This arc AP by this arc AP we get the angle theta at the center O, and by the same arc AP we get the angle theta dash on any point on the circumference B, any point B. Then obviously from geometry we get theta equal to 2 theta dash. This is the circumference angle by the same arc. Circumference angle theta dash and center angle is theta. So relation is theta equal to twice theta dash. It is well known relation, and differentiating this with respect to t, and we get d theta dt equal to 2 d theta dash dt. Now it is given that d theta dt is the angular velocity. So this is the constant angular velocity omega. This omega is constant, and this equals to 2 omega dash. Say here omega is the constant angular velocity is given that this. Here omega is the angular velocity of P, angular velocity of the point P with respect to O, center O, and this is the d theta dt. And omega dash is the angular velocity of P with respect to the any point B on the circumference, and this is the d theta dash dt. So this is the omega and this is the omega dash. Omega dash is the angular velocity of the point P, same point P, with respect to B, any point on the circumference. With respect to B, any point on the circumference. This is the angular velocity of P with respect to P. This is the d theta dash dt. This is the omega dash. And omega is the angular velocity of P with respect to the center O. Clear? So omega equal to 2 omega dash. Hence omega dash equals to half of omega, and this is also constant because omega is constant is given. So this is the constant. So angular velocity at any point, so the angular velocity about any point on the circumference is also uniform, and its value is half omega. This is the important result. This is the angular velocity about O, center, and the angular velocity about any point on the circumference is the half of the angular velocity at the center. Next question. (2004). The velocities of a particle along and perpendicular to the radius vector from a fixed origin r lambda r and mu theta. Find the path and also accelerations along and perpendicular to the radius vector. To the radius vector are lambda square r minus mu square into theta square by r and mu theta into bracket lambda plus mu by r. So this is the problem. Velocities of a particle along and perpendicular to the radius vector from a fixed origin O, some origin O, are lambda r and mu theta. So lambda is the radial velocity and mu theta is the cross radial velocity. It is given. Find the path. So we have to find the relation between r and theta and also the acceleration along and perpendicular to the radius vector. That means radial acceleration and cross radial acceleration. We have to find this. So first we draw the figure. Suppose this is the polar line OX. This is the O is the pole and this is the path of the equation and this is the tangent, the axis, the angle is psi and this point P, which coordinates in polar coordinates, is r theta. So join the point O and P. So this, the distance is r and this angle is theta. And so this is the radial, corresponding radial direction. This is the radial direction and perpendicular to this radius vector is the cross radial direction. Cross radial direction, and this is the angle between these 90 degree. By the given conditions, we have VR, that is the radial velocity, radial component of the velocity VR is equal to lambda r, and v theta is the cross radial component of the velocity is equal to mu theta. It is given. Now VR means dr dt, so this implies r dot equal to lambda r, and v theta means r theta dot. R theta dot equals to mu theta. So call it equation 1 and this is the equation 2. R dot means dr dt, theta dot means d theta dt. Here lambda and mu are both positive constants, fixed constants. These are given, lambda and mu. Dividing 1 by 2, we get dr dt by r d theta dt equals to lambda r by mu theta. So separating the variables, this implies mu dr by r square equals to lambda d theta by theta, and integrating this we get minus mu by r equals to this lambda we write in this side lambda 1 by lambda, so we write here lambda, this equals to log theta, log to the base e natural logarithm, plus log c, log c. C is the constant of integration, is the constant of integration. So after simplifying this we get minus mu by r lambda equals to log of theta into c. So theta c equals to exponential minus mu by lambda into 1 by r. So theta equals to 1 by c into e to the power minus mu by lambda into r. This is equation 3, and this is the C, required equation of the path. This is the equation which is in equiangular spiral. This is the required equation of the path which is an equiangular spiral. Now this is the path. Next part, radial and cross radial component of acceleration. Second part of this question. Radial acceleration is Fr equals to r double dot minus r theta dot square is the formula, r double dot minus r theta dot square. So this equals to ddt of dr dt minus r d theta dt whole square. So this we can write this 1 by r common, and we write this r into d theta dt whole square. This r square 1 by r cancel this r only, so we add this. Now dr dt is given by 1 is the radial component of velocity, so this is equal to lambda r. So ddt of lambda r minus 1 by r, this is the r theta dot, this is the cross radial component of velocity, so this is equal to mu theta, so mu theta whole square by 1 and 2. This equals to lambda constant, so lambda dr dt minus here mu constant, so mu square by r into theta square. Now dr dt means again putting dr dt means lambda r, so we get lambda square r minus mu square theta square by r by 1, and this is the result. This is the radial component of velocity. This proved. First, next part, cross radial component or transverse component of the acceleration. Cross radial acceleration. Cross radial acceleration, if theta is equals to 1 by r ddt of r square d theta dt. Now we write this 1 by r ddt of r into r d theta dt. R d theta dt. This r d theta dt means mu theta. Second equation, from second equation, 1 by r ddt of r into mu theta by 2. So this mu is constant. So mu by r ddt of r into theta. So differentiating with respect to time t, this mu by r, this is the r into d theta dt plus theta into dr dt. Now r theta dot, again we putting from 2, this equals to mu theta plus this dr dt is the equation 1, from equation 1 is the lambda r, so theta into lambda r by 1 and 2. So taking common, theta is equal to lambda plus mu by r, and this is the result for the cross radial component of acceleration. ঠিক আছে? Hello.
Hi sir.
Hi sir.
Next question. If the radial and transverse velocities, of a particle are always proportional to each other, so that the path is an equiangular spiral. Further, if this holds, for accelerations also prove that its velocity will vary as some power of the radius vector. If the radial and transverse velocities of a particle are always proportional to each other, so Vr is proportional to V theta, it is given, so that the path is an equiangled spiral. So we have to find the equation of the path. Further, if this holds for acceleration also, that means radial and cross radial acceleration proportional to each other, prove that its velocity will vary as some power of the radius vector. Velocity v is some power of the radius vector r. Here draw the figure as usual before. Given that radial velocity is proportional to cross radial velocity. So this implies Vr means r dot vary at r theta dot. So this implies r dot is equal to some constant k into r theta dot, where k is the variational constant. So this implies dr dt equal to k into r d theta dt. So separating variables, we get dr by r equals to k into d theta, and integrating log of r to the base e minus some constant c log c, this equals to k into d theta, sorry, k into theta, c is the constant of integration. Or log r by c equals to k into theta. So r by c is equal to exponential k theta, or this is the r by c equals to exponential k theta. So r equals to c into exponential k theta, and this is the equation of the path. This is the equation of the path. Here c and k are both constants. This is the required equation of the path, which is an equiangular spiral. Second part of this question, if radial acceleration is very as the cross radial acceleration, then Fr means r double dot minus r square theta dot, whereas 1 by r ddt of r square theta dot, or d2r dt square minus r square d theta dt equals to some constant variation lambda say by r ddt of r square d theta dt, where lambda is the constant of variation. Or d2r dt square minus here we write this r double dot minus r theta dot square, formula is wrong, r double dot minus r square theta r theta dot square full, এটা আমরা ভুল লিখেছি, এটা r theta dot square, r d theta dt square, so it is wrong. So this r into d theta dt, this equals to by 1 by kr into dr dt whole square equals to lambda by r ddt of r square, and d theta dt means from 1 by kr into dr dt by 1, equation 1. We put here value of d theta dt is equal to 1 by kr dr dt, and d theta dt is equal to 1 by kr dr dt from the equation 1. So or d2r dt square minus this r square, so this k square 1 by k square into r into dr dt whole square equals to lambda by this k constant, so kr ddt of r cancel, so r into dr dt or r double dot minus 1 by k square r into r dot square equals to lambda by k. Here after differentiating this r dot into r dot square, and this is equal to k into r dot square, because eta and eta differentiation plus eta into eta differentiation, r into d2 r d square, r cancel. So this equals to lambda by k into r double dot. This is the result, and after simplification you get r double dot equals to this r double dot here, this r double dot. So r double dot equals to, in terms of r dot common, r dot square common, so 1 by k square, 1 by k square plus lambda by k into r dot square by r dot square by r by divided by 1 minus lambda by k, this 1 minus lambda by k. So this lambda k are constants, so we can write r double dot equal to some constant n into r dot square by r, where n is equal to this constant 1 by k square plus lambda by k by 1 minus lambda by k, this is equal to constant. So r double dot equal to this, now r double dot can be written as r dot into dr dot by dr equals to n into r dot square by r. Why r double dot equal to this? Since r double dot means ddt of dr dt. This can be written as ddr of this dr dt into dr dt. So this dr dt means r dot, so we can write ddr into r dot into r dot. So r dot into dr dot dr, r double dot equals to this. So from this relation r dot dr and separating these variables, we can write from this dr dot by r dot equal to n dr by r. Integrating this, log of r dot equals to n into log r plus log c. C is a constant of integration. So r dot equal to c into r to the power n. C equal to, where is this constant? Obviously positive constant greater than 0. So r dot dr dt means velocity. That means or velocity component, radial component of velocity Vr equals to c into r to the power n. Equation number 2. Now from 1 r dot equals to k into theta dot into r, or r dot equal to c r to the power n, c into r to the power n equals to k into theta dot into r by 2. So r theta dot equals to c by k into r to the power n. Now r theta dot means v theta. So or v theta is the cross radial component of velocity is equal to c by k into r to the power n. This equation is 3. So resultant velocity of the particle, so the resultant velocity of the particle v equals to root over of vr square plus v theta square. So by 2 and 3, this vr square means c square r to the power 2n plus v theta square means c square by k square r to the power 2n whole to the power half by 2 and 3. Or c r to the power n common 1 plus 1 by k square whole to the power half. This k is constant, so this term is constant, so this is called capital A into r to the power n, where capital A equal to c into 1 plus 1 by k square whole to the power half is equal to constant. Therefore, the velocity is equal to a r to the power n, and hence the velocity v, this implies velocity v is proportional to r to the power n, and hence the result. Okay, any problem?
No, sir.
Okay, fine.
No, sir.
ঠিক আছে, we stop now here.
Okay, sir.